So we're going to solve the system of linear equations, and you'll notice that this one has fractions. Everybody hates fractions. And so what we're going to do is we're going to employ a technique called clearing the fractions. So what you do when you clear the fractions is you take the equation and you multiply everything by a common denominator. 35 times 1/7 is 5x, plus 35 times 1/5 is 7y, equals 35 times 1, 35. And we take the second equation, let's multiply everything by 4. So 1/2 times 4 is 2x, minus 1/4 times 4 is 1y, equals 1 times 4 is 4. Now what you'll have is two equations that are all whole numbers. There are no fractions. So this is cool. So you've gotten rid of the fractions. The equations are equivalent, right? These are the exact same equations. It's just one is in fraction format, the other one is in whole number format. So now what we're going to do is we're going to put these two equations together using elimination. So the top equation we'll just leave the same. The bottom equation we're going to multiply by positive 7. So that'll give us 14x minus 7y equals 28. By design, the 7's cancel, and we end up with 19x equals, what is that, 63? So x equals 63 divided by 19. That's your x. You take this x coordinate and you back substitute it into an equation and solve for y. So that'll be 2 times 63/19 minus 1y equals 4. Y is equal to negative 60/19. X is equal to 63/19. I like that attitude. Plug it in and see what happens. Submit. What? This should be negative 50, and then when we take the opposite, it should be positive. It's always easier to do these problems when you have 18 sets of eyes looking on to catch all your mistakes. Got it. All right, good. This process that we just went through is a common process. We did the vast majority of this problem correct, but you make one little mistake and your answer's not right. Sometimes this eats away at students. It's kind of like, oh man, I hate it. Why can't I just get them right? And that's part of the struggle of this class. That's what makes it tough. You have to learn to pick yourself back up and keep trying and keep trying and keep checking. So this is problem number 1 in 6.2. Yeah, solve for z, right? Z is negative 5. And once you know z is negative 5, you plug that into the equation above it to solve for y. And then once you solve for y, you plug both of those into the equation above that to solve for x. So this one's set up kind of nice. What do you notice about that third equation?
There's no z.
There's no z. So what if we took these two together, 1 and 2, and got rid of z? That would leave us with an equation of x and y that we could then put with equation 3. So let's try that. Let's get rid of z. Oh, look at that. Z's already set up real nice for us. So let's add them up. So we'll get 2x minus 5y equals 15. Now bring in equation 3, and we need to get rid of something. How about if we take this second equation, and let's multiply the second equation by negative 2. So that'll give us negative 2x plus 4y equals negative 12. That looks like a good move. So the x's cancel, and you get negative 1y equals 3, y equals negative 3. Back substitute that into the third equation and solve for x. X is equal to 0. Now take these two and back substitute them into the second equation and solve for z. Z equals negative 2. So we should have 0, negative 3, negative 2. Number 7 is tough. There are 3 variables, 3 equations. There are no missing variables in any equations. You have to do this one all the way out. So you kind of glass over everything. And I agree. Look at those y's. That's really nice. So what we're going to do is we're going to take equation number 1 and equation number 2, and we're going to get rid of y. Then we're going to take equation number 1 and number 3 and get rid of y. And it doesn't even look like we'll have to do any multiplying. We can just pair them up. So if we take equation number 1 and equation number 2 and we add them up, we'll get 15x. The y's are gone, they cancel. Minus z equals 41. And we're going to call this equation number 4. Then we're going to take equation 1 and equation 3, and we're going to add those together. And now we have two equations, equation 4 and equation 5, that both have x and z. So let's put them together, and let's do equation 4, equation 5, and what variable do you want to get rid of?
X.
How about x? An excellent choice. So 15x minus z equals 41, and negative 15x minus 6z equals negative 69. You add these up, the x's are gone by design, isn't that nice? And you get negative 7z equals negative 28. So z equals 4. Now that you have z equals 4, back substitute into one of the equations in the previous step. Probably this one right here. So take this 4 and back substitute it. So 15x minus 4 equals 41. So now we have x. Now take the value you have for z and the value you have for x and back substitute into one of the original equations. So we'll take the first equation and we'll say 5 times x, 5 times 3, plus 3y minus 5 times z, which is 4, equals negative 5. Y equals 0. So your ordered triple is 3, 0, 4. It's good. So here's a story problem. First thing you want to do is read the problem and understand what's going on. You basically have a collection of coins, nickels, dimes, and quarters. There's 19 total coins with a value of $2.30. The number of dimes is equal to the number of nickels. Don't try to guess and check this. Don't say, well, let's start with 10 dimes. Let's put that in and calculate it and see how many quarters I got to have. And don't do that. The very first thing you want to do is ID your variables. What variables are you going to use in the equation? Now we could use x, y, and z. That's great. But I like to use variables that mean something to the story problem. N, D, and Q. So N will equal the number of nickels, D is the number of dimes, and Q is the number of quarters. Now keep in mind, this is just the number of round, silver, shiny pieces of metal. It has nothing to do with its monetary value. So we're going to start out with an equation. Equation number 1. We're going to call this the coin equation. We understand that there are 19 coins. So that means the number of nickels plus the number of dimes plus the number of quarters equals 19. The value equation. And specifically, we're going to measure this in cents. And so there are 5 cents for every nickel, plus 10 cents for every dime, plus 25 cents for every quarter, for a total of 230 cents. The only place where you put a value on the variable. It's the only place where you have 5n, 10d, 25q. It's in that equation. The number of dimes is equal to the number of nickels. D equals n. Equation number 1 and equation number 2, and get rid of q. That will give you an equation in terms of n and d. You can then take that equation, and don't forget this equation over here is actually d minus n equals 0. So to get rid of q, I think we should multiply equation number 1 by negative 25. And the second equation, we're just going to leave it as is. Now we're going to add them up. So that'll give us negative 20n minus 15d, q's are gone, equals 245. There's a multiple of 5 in all of that, so we could take out a 5, and let's take out actually a negative 5. N equals d. So that means we can replace this d with an n. 7n equals 49, n equals 7. So if you put a 7 in for the nickels and a 7 in for the dimes, q has got to be 5. You should get whole numbers for story problems. You don't ever want to have 2/3 of a nickel. So if you work these problems out and you get a decimal or a fraction, go back and double check your work. Something's wrong. 7, 7, 5. Survey says green.